All right, we're on problem 17 here. So let's see. It says, does the graph below represent a function of x? If it is a function, write yes and state the domain and the range. If it is not a function, write no and explain why not. Okay, so one of the really important things that we have to look for in order to call something a function is that it's got to pass the vertical line test. So if I swing a vertical line across the graph, any vertical line that I would draw is going to intersect the curve in only one spot everywhere. Okay, so this is going to be a function. So I'll write yes, and then state the domain and the range. Okay, the domain is asking for the x values. So if I scan the x-axis, look above and below each spot. If I'm on the curve, I'm in the domain. If I'm not on the curve, I'm not in the domain. Well, here, let's see, here's -4 to 4. If I look specifically below, I'm going to be on the curve from -4 to 4. Okay, I'm including -4 and I'm including 4. In other words, the point -4, -2, and 4, 2, those are points on the graph. Okay, so the conditions on x are that x is greater than or equal to -4 and less than or equal to 4. Okay, to get the range of the function, I need to scan the y-axis and look to the left or the right. If I'm on the curve, I'm in the range. If I'm not on the curve, I'm not in the range. Okay, so well here, it looks like anywhere that's between -6 and -2. When I look to the left or the right, I'll be on this curve here. Okay, here's another change for the range. So make sure that you're using the variable y whenever you're describing the range of a function, not x. X is representing the domain. Okay, so I'm going to say the set of all y values such that y is between -6 and -2. Now I'm including -6 because the point 0 and -6 is on the graph, and I'm including -2 because the points 4, -2, and -4 and -2, those are on the graph. Okay. In problem 18, it says, does the graph represent a function of x? If it is a function, write the domain range. If it's not a function, say no and explain why not. Okay, so for a function to happen, it's got to pass the vertical line test. Right, we said that. So if I draw a vertical line anywhere on this graph, a vertical line drawn is going to intersect the curve in 2 points. You can't have that with functions, right? We know that for each x, there's only one y. There's not two y's, right? I got a y value up here and a y value down here. I can't have that with functions. Okay, so this is not a function because it's going to fail the vertical line test. Now, if I draw a vertical line over here, you know, I'm all good over here. I don't have any graph over here. But that's not what the test says. It says if every vertical line intersects the curve, and at most one point, then the graph is a function. So where the test fails is anywhere on this side of -2. Okay? All you need is one vertical line for the whole thing not to be a function. Okay? Now there's going to be lots and lots of times where we're going to need to use the vertical line test. Okay, and obviously whenever we draw a function, we want to make sure that it passes the vertical line test. If we draw a curve that fails the vertical line test, like I know right away that you have a wrong answer if you're describing a function. Okay? All right, so let's try problem 19 next. We have a piecewise function, so there's 2 pieces here, and there's conditions on x. In part A, they want us to evaluate f of -3, f of 4, and f of 5. Okay, so one of the things that you have to do whenever you're working with a piecewise definition or a piecewise function is that you got to pay attention to which piece you're going to plug the number into. Okay, so -3 is between -4 and 3. -3 is not between 3 and 5. So I'm going to do nothing at all with piece 2. And specifically, I got to plug in -3 into piece 1. Okay, so -3 minus 3, that's -6. So the point, -3, -6, that would be on the graph. Okay. Let's find f of 4 next. Well, 4 is not between -4 and 3. 4 is between 3 and 5, right? So when I plug 4 into the function, specifically it's got to go into piece 2. And I'm going to do nothing at all with piece 1. 4 plus 1 is 5. Okay, so the point 4 or 5, that point would be on the graph. Okay. Now, whenever you have piecewise functions, you're only be plugging the number into one piece. I sometimes see students will make a mistake and they'll plug in this number here into each and every piece. Don't do that. Don't do that, because if you do that, you've completely missed the idea of a function. Okay, so the number is only going to go into one piece. F of 5. Okay, well, this function is defined up to 5, but not including 5. So f of 5 would be an undefined value. Okay. Now, whenever I'm graphing a piecewise function, there's going to be several pieces here. I have a closed circle whenever I'm including the number, and an open circle whenever I'm not including the number. Okay, I'll talk about that again in part B here. So which graph below represents the graph of f of x? If I plug in -4 into piece 1, -4 minus 3 is -7, right? So the point -4, -7, that point has to be on the graph. Okay, so I know that the answer is not A, because I don't see the point -4 and -7 on this graph here. So A is out. B is also out, right? -4 and -7, that's down here. And we don't have any graph down here. And so B is out. Okay. Now here is -4, -7. That point has an open circle on it. Okay. Again, whenever you're including the number, you have a closed circle. So because I'm including -4 and I'm including 3, I need closed circles on both ends here. These are open circles. If x is 3, 3 minus 3 is 0, right? So 3, 0 should be on the graph. Okay, and then we said that -4 and -7 is on the graph. Okay, well, it's not going to be this curve, right? Because these have open circles. So it's going to be D is the answer. Okay, here's -4, -7, and here's 3, 0. Now in piece 2, if x is 3, 3 plus 1 is 4, so 3, 4, that can't be on the graph, right? That's an open circle because I'm not including 3. I'm also not including 5. 5 plus 1 is 6. So 5, 6 should not be on the graph also. That has an open circle on it. Okay, the answer there would be D. Okay. Now, when you have piecewise functions, the curves that you're going to be drawing are either going to be one of the basic functions or a line. Okay, so these are lines. And we're going to do lots and lots of things with lines in chapter 2. Okay, so more on that later when we get there. But okay, part C, it says to state the domain of f. The domain is asking for all the x values. Write your answer using set builder notation or interval notation. Okay, so the conditions on x are that x is ranging between -4 and 3. We're including -4 and including 3. And then anything bigger than 3 up to 5. So if you combine all that, you're essentially saying that x has to be a number that is between -4 and 5. including negative 4. Okay, so the domain of the function, I'm going to say the set of all x such that x is greater than or equal to negative 4 and less than 5. Okay. Let's try problem 20 next. So in problem 20, we have this piecewise function, okay, and they want us to evaluate f of negative 1 and f of 1. Okay, so negative 1 is less than 0, right? So when I plug in negative 1 into this function here, it's going to go into piece 1. Negative 1 squared, negative 1 times negative 1, that's 1. Okay, so 1 would be the answer. And the point negative 1, 1 would be on the graph. Okay. In the other part, we're plugging 1 into the function. Okay, well 1 is between 0 and 4. So I need to plug that into piece 2 there. Okay, 1 minus 2 is negative 1. So the point 1, negative 1, that point needs to be on the graph. Okay. In part B, we're supposed to graph f of x. Now, in piece 1, I have the basic function y equals x squared. You're going to do lots and lots of things with y equals x squared in the next chapter. Okay? Y equals x squared is the square function. Okay? And so I'd have the parabola here. Now, I don't want this whole parabola. Okay? I only want the part of the parabola to be showing when x is less than 0. So if I drew the whole parabola, anywhere that would be to the right of 0, I would need to erase. And anything less than 0, I would keep. Okay? And x is strictly less than 0, so the point 0, 0, that should not be on the graph. Okay, piece 1 is now done, and we're graphing piece 2 now. So piece 2, I have x minus 2. Okay, if x is 0, 0 minus 2 is negative 2. So 0, negative 2, that should be on the graph. And then if x is 4, 4 minus 2 is 2. Okay, 4, 2, that point should not be on the graph, right? Because we're strictly less than 4. So I have an open circle there on the right and a closed circle on the left. If I draw a line between those 2 points there, then that would complete this function. Okay. Now you got to pass the vertical line test. So if I swing a vertical line anywhere, across this graph, it's going to only intersect the curve in one point everywhere, right? Even at x equals 0 here, because the point 0, negative 2, that's on the graph. We said 0, 0 is not on the graph. Okay. So this curve would be the completed function there. All right, part C, we want to state the domain of f. Okay, so let's see. The conditions on x are where x is less than 0, also x is less than 4 and greater than or equal to 0. So when you combine these two parts here, you're essentially saying that x has to be a number that's less than 4. Okay, now I can get that same answer from this picture. Okay, if I scan the x-axis, look above and below each spot. If I'm on the curve, I'm in the domain. If I'm not on the curve, I'm not in the domain. Well, anywhere that's less than 4, if I look above or below, I'm going to be on the graph. Right? The arrow indicates that we're going upward and outward towards the left. So we're going to cover the whole x-axis there on the left side. Okay, and here'd be my answer. And I could also use interval notation as well. So I'd say negative infinity to 4. I just make sure to have a parentheses at 4, right? Because we're not including 4. There. Okay, we'll go ahead and stop the video right here, and I'll pick up with problem 21 in the next video.